Hey everybody, thanks for tuning in here. What we're going to look at today is we're going to go back to talking about inequalities here a little bit, but combine it with that idea of looking at a system. So let's just do a quick review here. If I have an inequality such as y is less than 2x minus 1, do you remember how we were graphing these? That we had to come up with a boundary line, and with that boundary line, okay, we had to decide if it's solid or dashed, and then we had to determine, do we need to shade above or do we need to shade below that line? Remember that the solutions to the one inequality are the points that make the inequality true. So let's just do this quick review one, and then we'll look at what happens when we have a system of more than one inequality. So when we graph y is less than 2x minus 1, we're thinking about y equals mx plus b. The slope on this one is 2, and the y-intercept is -1. So let's graph that. We're going to put a point at -1 for our y-intercept. Our slope is 2, which means we're going to go up 2 over 1. And I have this line. But as I just graphed that, I realized that I have to think about something that I didn't think about yet. Look at this inequality. This is less than, which means we need to take our line and we need to make it dashed. I don't know why it moves that. I'm going to do that again. Let's just use the dashed line tool instead of that eraser. There it is. That's because any point that is on that line, remember, is not a solution. So we want to make sure it doesn't look like it's included. If I pick this point 1, 1 and I put it in, is 1 less than 2 times 1 minus 1? Well, is 1 less than 1? No, it's not. So it should not be included. That's why this line is dashed. Now, do we shade above this line or below the line? Where are the y values that are less than this line? Well, those are the y values that are less than, that are underneath what we have there. Okay, so I'm going to shade everything underneath our line. So this means that every point in that shaded region is a solution to that. So let's say I picked, let's pick a point here, 1, 2, 3. Let's pick this point, 3, 1. Okay. Well, if I plug in 3, 1, is 3 less than 2 times, 3, 1, is the y value is 1. Is 1 less than 2 times 3 minus 1? Well, 2 times 3 is 6 minus 1 is 5. Is 1 less than 5? Yes, it is. That's why that point is included in the shaded area. But if I picked a point over here, like this one, -1, 2, and if I plug that in, is 2 less than 2 times -1 minus 1? 2 times -1 is -2. Minus 1 is -3. Is 2 less than -3? No, it's not. That's why this point is not shaded in. It's not part of our solution. So now let's take this, which we already knew how to do, and let's expand it to a system. Notice here there are 2 inequalities. Now, our solutions to a system of inequalities are going to be all the points that make all the inequalities true. So in this case, there's 2 of them. The solutions are going to be all the points that make both of these true. They have to work in both. So how do we approach this? There we go. Let's get me out of the way. Let's go up there. That's a good spot for me. Hi, everybody. Well, we just graphed this one. We know what that was. slope was 2, y-intercept was -1. So there's -1, there's my slope of 2. That again is a dashed line that looks like that. And we shaded that one below, didn't we? Well, now let's move on. And let's go to this inequality of y is greater than or equal to -2/3 x plus 1. Well, here our y-intercept is 1. Whoop, very large point. That looks better. Our y-intercept is 1. Our slope is -2/3, so that means we're going to go down 2 over 3. Now, should this line be solid or dashed? Well, this is greater than or equal to. The or equal to tells us we need a solid line. Now, where are the y values that are greater than the points on that line? Now we're shading above, aren't we? All right. So now remember, up here, where I said that the solutions are the points that make all the inequalities true. So where are the points that work in both this top inequality and the bottom inequality? Well, all the points that worked in the top inequality is this red dashed line, and where we shaded it as kind of a pink color. All the points that worked in this one were that blue solid line, and everything that I shaded that light blue. So where are the points that were in both of them? Well, it's the points that we shaded both times, and we can see it's this region right here. So our solution are going to be all of the points Gosh, that's got a weird effect, doesn't it? I don't know why the eraser does that, but there it is. This region right there, now it's not truly a triangle because it goes on forever in that direction, but these are the points that work in both. Let's test it. Okay. Let's pick a point. Pick this point right there. What is that point? 1, 2, 3, 1. 3, 1 is in the region that we shaded both times. Try it in the top one. Is 1 less than 2 times 3 minus 1? Yes, it is. How about in this one? Is 1 greater than or equal to -2/3 times 3 plus 1? Well, -2/3 times 3 is -2, plus 1 is -1. Is 1 greater than or equal to -1? Yes, it is. See how that point worked in both of them? That's a solution. So is every other point that we have shaded. Now, if it's this point, that's on the dashed line, that's not a solution. How about this blue point right there? That's on the solid line, that is a solution. Now, how about a point out here? Now that one, I believe, we had originally shaded. That was part of being shaded above this blue line, wasn't it? So we shaded it once, but did we shade it both times? No. So what happens if I put the point 0, 3 in? Is 3 less than 2 times 0 minus 1? No, it's not. Although 3 is greater than or equal to -2/3 times 0 plus 1. 3 is greater than or equal to 1. That works, but it didn't work in this one. That's why 0, 3 is not a solution. So really, the systems of inequalities is not much of a step beyond what we're doing right here. We just have to do this multiple times, and our solution is the area that we shade every time. Now, I know that you guys don't have the technology I have here. I like to erase everything else. But I totally understand on your work that you're going to shade one area, you're going to shade another, and it's really hard to go back and erase those areas that you only shaded one time. So we'll just make sure that on your practice and on your assessments, your tests, that you just make this region really clear. I'll show what I mean on this next one. All right, so let's graph the solutions to this system. We have 2x plus 3y is greater than 9. We have 2x minus 3y is greater than 9. At first glance here, I thought, oh, maybe these are the same inequality. I wonder if this is one of those no solution, infinite solutions, but this one is a minus. So I have a feeling they're a little bit different. Let's graph the first one. Now this is in standard form. In standard form, two options. You can get it to y equals mx plus b. I can subtract the 2x, I can divide by 3. Or we can find the x and y intercepts, which is what I prefer. If you like y equals mx plus b, I totally get that. But let's take that first one. X-intercept. 0 in for y. 2x 2x plus 3 times 0. Oh, I'm getting kind of a dead spot on my Mobi there. Equals 9. Okay, that's 0. We just need to divide, so that's gone. Divide that by 2. X equals 4.5. 1, 2, 3, 4.5. The y-intercept, 0 in for x, 2 times 0 plus 3y equals 9. Notice that's gone. Divide by 3, divide by 3, y equals 3. 1, 2, 3. Looking at this, I notice my line should be dashed. All right, now I need to determine, do I shade above or do I shade below? Well, when it's in standard form, it might not be as easy to determine. Remember, you can always test a point. How about 0, 0? Is 2 times 0 plus 3 times 0 greater than 9? Certainly not. So we are going to shade not where 0, 0 is, but on the opposite side. Okay, we need to shade up here. All right, let's go to the next one. X-intercept. Maybe we can do this without doing so much work. Wouldn't the x-intercept still be 4.5? How about the y-intercept? Is it still 3? No, if we have that being a 0, we need to divide by -3. So we get a y-intercept of -3 instead of +3 because of that negative. So same x-intercept. Y-intercept is at -3. Again, this is a dashed line, isn't it? Looks like this. Do we shade above or below this one? Test to point 0, 0 is 0 minus 0 greater than 9. No, so on this one, we have to shade below. So now, where is our solution? Where is the area that we shaded both times? Now be careful, this is hard to see because we're kind of running out of graph. It's this right here, isn't it? Okay. So what I would expect of you guys is that maybe you guys could make these lines a little bit longer. and then make it very clear to me that the area that you are shading multiple times, see if I just keep shading it like this, so it just keeps making it darker, should be really clear to everybody. That is the region that is our solutions. All right, good job. Let's look at another one. All right, y is greater than or equal to -2. X is less than or equal to 1. I threw in here a couple that aren't in our y equals mx plus b form necessarily, or our standard form. They just look a little bit different. Just wanted to remind you guys, y equals -2 is what kind of line? It's a horizontal line, isn't it? So I'm going to graph y equals -2 by putting a point at -2. Whoops. Let's try that again. A point at -2, and it's a horizontal line. Should this horizontal line be solid or dashed? Okay, it should be solid. It has the or equal to. And are we going to shade above that or below that? That would be above, wouldn't it? How about y is less than or equal to 1? Well, where does y equal 1? Where does x equal 1? X equals 1 right there. This is a vertical line, isn't it? Okay, it's going to be solid because that's greater than or less than or equal to. Are we going to shade to the left or right of this one? That's the question when the line's vertical, isn't it? Where are the x's that are less than 1? They're on this side, aren't they? They're to the left. So, my expectations on your practice again. What's our solution set? Where are our points that were shaded both times that work in both of these? That's this region right here. Just make sure that that is shaded nice and dark, so it's super clear to everybody. Pen's glitching out. There we go. That's better. Okay, that's our region. They include these solid lines. If you're like me, though, you might want to go back and erase everything that's not. You don't have to do that on your practice. You can just shade that in as dark as you can. Questions so far? Good. I feel like you've got it. I want to look at two more special cases. You're not going to be surprised here on what's going to happen on a couple of these. All right, let's graph this. Here's our system. First one, y is less than 1/2 x plus 3. Our second one, y is greater than 1/2 x. You may notice already they have the same slope, don't they? But they have different y-intercepts. What's true about these two lines? They're parallel, aren't they? Our first one, y-intercept is 3. Slope is 1/2, up 1 over 2. This line is dashed. Are we shading above or below this one? This one is below. All right, we go to the next one. What's our y-intercept? This is really plus 0, isn't it? So our y-intercept is 0. Our slope is 1/2, up 1 over 2. This line is also dashed. And this one, we are shading above that line, aren't we? Whoa, getting excited here. All right, so this one got a little bit messy, but this is actually kind of a neat graph. Where is it that we shaded both times? We shaded between these parallel lines, didn't we? We get this really neat kind of graph. Looks like that if I grab my eraser to clean up some of this other stuff. Getting rid of that. You know what, I think my kindergarten daughter is better at coloring in the lines than I am, but you know where that's supposed to be. Look at that. That's kind of a nice, neat graph, isn't it? Can you guess what I'm going to ask next? Look at our next one. That's the same, isn't it? Isn't that the same? Okay, what's different? Okay, look carefully. What's different at this and on this one? Notice this was a less than. That was this red dashed line we shaded below. Now it's a greater than. We're going to shade above it. The lines didn't change. We're still at a y-intercept of 3. We're still at a slope of 1/2. Y-intercept 3, slope of 1/2. But now we're shading above. This one, we're shading above as well. That's exactly like what we had before. Y-intercept is 0, slope of 1/2. And we're shading above. That one colored up really nicely. Where's our solution area here? It's just everything above this red line, isn't it? We got to get rid of everything in here. Just all of this above that line. So if I wanted, I could erase this and try to clean that up. Final question. What if I wanted this to be no solution? What if I didn't want any points in my region? What would I have to change about that system? Well, if you said that if we shaded below this blue line and above this red line, there would be no overlap, would there? So how would we change that? If I change the bottom one, if I left the top one above the line, but made the bottom one below, that would be no solution. All right, so there you go. That's our systems of inequalities. Like I said, it's not a big step above what we did before. You're just looking for that region that we shade multiple times. Thanks for tuning in. Catch you on the flip side.